Hi everyone, just wanted to take a minute to talk a little bit about geometric sequences and some of the different means that you can use to solve problems and answer questions relating to them. So a geometric sequence, similar to an arithmetic sequence, has two different forms. We have an explicit formula and we have a recursive formula. Ultimately, they can both be used to solve problems relating to geometric sequences. But kind of their usage might differ depending on what information you have. So first off, what is a geometric sequence? Well, a geometric sequence is a sequence, which again, just some ordered list of numbers, where each term differs by a common ratio. So now, as opposed to before with an arithmetic sequence where we were saying like 1, 2, 3, 4, right? We were adding 1, adding 1, adding 1. That would be an arithmetic sequence. With a geometric sequence, we're not going to be doing that anymore. We would have something like 1, 2, 4, 8, 16, and so on, right? I keep multiplying now. I have a ratio. I keep multiplying by the same thing. Times 2, times 2, times 2, times 2, and so on, right? You can multiply by a fraction. You can multiply by a decimal. You can multiply by a positive number, by a negative number. There's all kinds of things you can multiply by. The only restrictions on it are you're obviously not going to multiply by 1 every time, because 1 times 1 every time is not really so much a sequence as it is just the same number over and over again. And similarly, you're not going to multiply by 0 because after the first one, it's just 0. So outside of that, pretty much anything is fair game. So what do we actually have here? Well, we have the explicit formula. So the explicit formula is in this means, right? We have the nth term, some random term. If I want the 47th term, right, it would be the 47th, 47th, right? 47th term. And it is equal to the first term, your initial value, the first term being, again, the first one in the sequence, times your common ratio raised to the n minus 1 power, all right? So, for example, if I wanted the 47th term and I had an initial term of 2, right, and of r, a common ratio, this is what I'm multiplying by every time of, 1/2. I would have 2 times 1/2 to the, and I want the 47th, so the 47 minus 1, which is 46. All right, so that would be how you get some far off term. It's really useful if you don't necessarily have a lot of the information. It's except for the common ratio in the first term. It's really helpful for getting things far away from other things you have. If you have to just find the next term, or maybe 1 or 2 away, the recursive formula is very useful. So the recursive formula, much like the recursive formula of the arithmetic sequence, basically says the following. If I want the nth term, well, that's easy. I just take my common ratio and I multiply it by the n minus 1 term. So I just take the previous term and multiply it by my common ratio, and I get the next term. And that's all it is. So if I needed the 7th term, I would say, well, that's easy. I just take my common ratio and I multiply that times the 6th term. And then you go, okay, well, that doesn't tell me. I don't know what the 6th term is. And so you say, okay, well, I know what that is. That's easy. You say it's the 6th term is the common ratio times the 5th term. And then you can continue on and so forth until you get back to the beginning. You do need to know the initial term for this, right? You need to know a starting point, and you still need to know the common ratio. All right, so let's do a little bit of practice with these. So if I go over here into Delta Math, we can see I could write the recursive formula for this sequence. First of all, you should verify that your sequence is actually an arithmetic sequence. I'm sorry, not an arithmetic, a geometric sequence. Because if it's not, then don't use the geometric sequence information. So if we have 48 and I go to -12, right? I'm at negative 12 over 48 is going to be what? Well, these are both multiples of 12. 12 times 1, 4 times 12. So it would be negative 1 over 4. And let's just confirm that that pattern continues. So if I did the next one, I'd have 3 over negative 12. All right? So it would be, again, divide by 3, 1 over negative 4, so it's the same. So my ratio is going to be this number. This is my ratio, my negative 1/4. And what is my first term? Well, it's given to us, it is 48. So my initial term is 48. And this would be, and I want the recursive formula. So if I want the nth term, I just say I take my common ratio, which I know is going to be negative 1 divided by 4. And I just multiply that by the prior term. And there you have it. Now let's make sure I didn't make a mistake, and we're good. All right, let's try one more for good luck. Okay, let's look once again. So what do I know? I have 25, negative 5, 1. So negative 5 over 25, well, that's clearly going to be negative 1/5. And then 1 over negative 5 is going to be, well, negative 1/5. So it is geometric, so that's good. We have to write our initial term, right? You need the starting place. So that would be 25. And we know it is, again, going to be negative 1 divided by 5. 5 times the prior term. We have. All right, now let's do a little bit of practice with the explicit. So let's just find the 10th term of the geometric sequence. Now, obviously, what could I do? I could go through the process of multiplying each one kind of repeatedly, and I would get there eventually. Maybe not quickly, but I would get there. Let's go through the process of actually writing the explicit formula. So first of all, we need to ask ourselves, what is the explicit formula? Well, we're saying that the nth term is just equal to, if we recall, the first term times ratio, the common ratio, the n minus 1 power. Now, you might be asking yourself, where does that come from? That just comes from the recursive formula, right? If I did this, if I told you I wanted the recursive formula, you would have told me it was this. And then I would have said, well, what's n minus 1? And then I would have told you this. And you could have kept going like that. Ultimately, what ends up happening is if you substitute these back in, because I just know that, now this is equal to r times a to the n minus 2, right? You can keep going all the way down until you get down to 1 and substitute in. And anyway, you'll end up with n minus 1 r's. Okay, so let me just clear that. So this is what we want. A 1 r n minus 1. All right, so what am I looking for? I am looking for the 10th term of the geometric sequence. So first of all, what do I need to figure out? I need to figure out my initial term. That's easy. I just look and go with 8. Okay, and now if I need the 10th term, I still am missing the ratio, so I need the ratio. So what's that going to be? Well, let's do 16 over 8, which is negative 2. 32 over 16. And I always want to do 2 just to confirm. This one's pretty straightforward. You can see it's going to be negative 2 pretty quickly. Don't forget, when you have a negative that you multiply repeatedly, it's going to kind of create this like, jumping pattern where it goes positive, negative, positive, negative, positive, negative, negative 2. All right, so it would be negative 2. So my explicit formula is going to be 8 times negative 2, and be careful, this negative 2 is in the parentheses, don't forget that, n minus 1. And I want the 10th term, so that is ultimately going to be 8 times negative 2 to the 10 minus 1. 8 times negative 2 to the 9. What is negative 2 to the 9? Well, we know it's going to be negative because it's an odd number, power, but I don't know what 2 to the 9th is off the top of my head, so you can look that up. It's 512, as I just learned. The other thing you could think of is the 8th would be 256, which is very common for computer science with bits. But anyway, and then you just multiply by 2. So that would be 8 times negative 512. All right, so what is 8 times 512? Oops. Negative 4,096. Could you have done that out? Yes. How else could you have thought of this? Well, you know this is negative 2 to the 9th. 8 is going to be 2 to the 3rd, right? 2 to the 11th. 2 to the 11th, if you want to just confirm that. Oop. 2 to the 12th. I'm sorry, I can't add. 2 to the 12th, if you were to check on that, it'd be 4096. All right, so anyway, negative 4,096. And we're good. Let's try one more. All right. I don't want to do that one. That one's too straightforward. Let's do a little bit harder of one. Okay, let's do this one. So we have 6, 24, 96. All right, so ultimately, what do I need? My ratio and minus 1. Okay, so I need my first term. That's easy. That's just 6. My ratio is going to be 24 over 6, which is what? 4. And that would be 96 over 24, which is still going to be 4. Okay, so my R is 4. So my 9th term is going to be 6. I can't read. Times 4 to the, what am I, 9? Okay, 9 minus 1 is 8. All right. I don't know what 4 to the 8th is off the top of my head. I'm going to be perfectly honest. I have no idea what it is. I could figure it out, but I don't know what it is. It's, okay, 65,536. Yeah, I wasn't pulling that one out anywhere. So that would be 6 times 65,536. Now I'm going to multiply that times 6, which, don't do that by hand. I mean, you can. I know you have the capacity to do it, but why? Okay. Also, don't forget, you can look it up in a chart. Well, you can look up this part in the chart and then just multiply by 6. So anyway, it would be 393,216. There you have it. Let's just make sure I didn't make a mistake on my multiplication. I did not. So anyway, you do see very quickly that these can get very big. Just keep that in mind when you're kind of looking at your answers. If you are multiplying by something really big, like 4 is not even that big of a ratio, right? If you're multiplying by something like 8 as your ratio, it's going to get very big very quick. So just keep that in mind when you're looking at these problems. All right. Let me know if you have any questions, and have a great day.